Good morning, everyone. It's about 8:04 a.m. Pacific Daylight Time, I think, and it is Tuesday, September 3rd, 2024. I am Nate Boot, a developer advocate for the OpenSearch project, and this is our community meeting. Thanks for coming, everybody. Chris actually has managed to score two presenters for today. So we've got two people coming to share some cool stuff with you. And before we get to any of those specifics, let's do our normal, sorry, I got a cat right next to me. Let's do our normal community meeting housekeeping kinds of stuff. And my
Go for
face
it.
turned from purple to white. Pow. All right. Please introduce yourself before speaking. Please mute yourself unless you're actively speaking. Cameras are optional. Questions anytime in the chat or audio, although since we have presenters today, if they have a preference, let's try to accommodate our presenters today. Disruptive folks will be removed. We've gotten very good at it. It won't take long. Don't think you can speed spam us. Announcements. Oh my gosh. Chris, can you believe that OpenSearchCon North America 2024 is still coming up?
It
What
is coming so quickly.
what do we
And
got? 3 weeks? Like almost exactly 21 days, I think.
something like that. Is it really that? Yeah, it is that
Yeah,
soon.
exactly 3 weeks from now.
Goodness. Yes, let's get everyone there. I think it's going
Yeah.
to be a lot of fun.
My Jedi senses Chris will have these links in the chat before you could snap your fingers.
Already there.
Look at that. Awesome. So yes, please do give a thought to attending. I realize not everyone can fly to San Francisco for a conference, but I believe that it will be well worth your time if you can somehow talk your employers into sponsoring that travel. I think there's actually a lot of good web resources on like how to convince your boss to approve your attendance at a conference, things like that. If you're like if you think you can get your work to sponsor your traveler, and it's a free conference, so that's all they'd have to sponsor. That would probably be worth your time. Probably worth your time. Awesome. So our two presenters today, we've got Tudor Golubenco. Uh, there. So, correct me if I'm wrong here, Tudor. So you're a CTO at is it Zeta or Seda?
Xata, yes. Yes, you
Zeta.
can.
Okay.
Yeah, it comes from extended data. So if you pronounce data, then it's Zeta. If you pronounce it data, then it's data. We actually fine with any pronunciation.
And I like it. I like it. And so your company slogan is Postgres powered up.
Yep, I'll be speaking more about that.
Nice, nice, awesome. And then we have Siddharth with us from ReactiveCo. You guys specialize in a search interface that kind of helps people adopt AI into their normal website searches.
Yes, AI as well as face-edited search.
Awesome. Well, if no one has anything for the good of the order, I have no further announcements or anything like that. Should we jump right into the presentations? All right.
Yep.
Have at it. Feel free to take over the screen share at your convenience.
All
And
right, just
we'll get
doing it now.
face off camera.
All right, there we go. Hey, I'm Tudor. I'm CTO at Zeta. As has been mentioned, I will speak about replication from PostgreSQL to OpenSearch via a new open source project that's called pgstream. First, a little bit about us, about Zeta. We are what we call a Postgres database platform. What that means is that we offer a fully managed Postgres service, a little bit like RDS or something of that kind, but with a few things on top. And these few things on top are meant primarily to address common pain points that people have when they operate Postgres at a certain scale. So we bring things like branching, We bring things like major version upgrades without downtime. We have automatic replication to OpenSearch, which is where pgstream was born from, kind of. We have a bunch of improvements around schema migration. We had as another open source project of ours that brings zero downtime reversible schema migration for Postgres. And all this comes with like excellent support. That's kind of the company pitch, if you want. Now, besides the Postgres database platform that we are offering it as a service, some parts of it we have separated and made them open source. The reason is so that people don't get vendor lock-in when they choose these improvements and start relying on them on the Xata platform. We make it, by making them open source, it makes it easier for people to leave if they ever want to. But it's also a way for us to grow a little bit the community around some of our most interesting tech, if you want. And we have at the moment 3 open source projects. There's pgrole, which is the one that I mentioned. It's about schema migrations for PostgreSQL. We have pgzx, which is a framework for creating Postgres extensions using the Zig programming language. It's also very interesting. And we have pgstream, which is Postgres CDC change data capture, including DDL replication changes. And this is the one that we're going to talk about today. As I was saying, it's an open source project, Apache licensed, and it's, if you want, it's different from other CDC tools in the sense that it's very focused on Postgres, and it includes schema changes in addition to data changes, because most other CDC tools for Postgres, I would maybe even say all of them, only give you data changes. But if there's an alter statement or something changes in your database, you don't get an event for that. So you cannot, on the consumer side, you cannot react to that. So that's like, if you want, the main differentiator. And we have open source pgstream, as I was saying, it was something that we were doing internally in Xata. We figured this is a pretty generic problem that other people will face. So we thought to open source our technology, if you want. So the motivation for it, as I said, it's a very Postgres specific CDC tool. Again, most other CDC tools tend to be generic, supporting a lot of inputs and a lot of outputs. We will only support one input, Postgres, but take advantage of all the Postgres functionality. So we make a really good one for it. And then there are multiple outputs. At the moment, the OpenSearch / Elasticsearch output is the most advanced, because that's the one that we use heavily internally. And we have another one for calling webhooks. And we plan some more. We can talk about that at the roadmap section. And besides what I was saying, that it includes schema changes, reacting to schema changes, it just handles a lot of the more tricky replication problems that come with replication between Postgres and OpenSearch. So that things like performance improvements by doing batch insert, batch indexing, update if the events, doing updates correctly if the events are out of order, handling column renames, handling large values, and more. We'll see later in the presentation. I'm just opening the chat a little bit to see if there's any questions. No, great. Yeah, I forgot to say, feel free to interrupt me at any point in time if you have questions. I will be glad to answer. So in the demo that I'm going to show, I will show this very simple setup. So we have Postgres, OpenSearch, and the pgstream process between them, copying data and keeping it in sync from one to the other. However, pgstream can be deployed also with Kafka in the middle, and then you can run, pgstream from Postgres to Kafka, and then pgstream from Kafka to OpenSearch. Is the same program that you're running, just with different configuration. And by having Kafka in the middle, it gives you some advantages at scale. You can replay data from Kafka. You can do, like, and there's good reasons for which you might want to do that. I'll start with a simple demo. Let's say the happy path demo. And then we're going to look at the more complex use cases. But first of all, what we have here, basically an empty OpenSearch instance. There's you see only the default indices there. And then also this is our Postgres instance that I'm connected to. It's also empty. So what I will do first is call pgstream init. And what this does is it creates, if we look at the schemas now, it created this pgstream schema in Postgres, where pgstream stores a few things of its own. We'll see in the future. And now let's start pgstream itself, which I will do with this command, pgstream run, and the configuration file. Let's actually look at the configuration file just for a little bit. It's from Postgres to OpenSearch, and it's configurable basically via environment variables. And these are the environment variables that are relevant here, basically where to connect to Postgres, and this is where to connect to OpenSearch, and then a number of options for batching and this kind of stuff. So if I start it now, and now I can start doing some stuff here in Postgres. So I will start by creating a table. Let's create table employees with a few columns. And let me also insert some data so that we have some, inserting a single row. And now if we look here, let's see what indexes shows up. There's a pgstream index, which is again kind of pgstream internal, where it stores some things about the schema that it's dealing with. And then there's this public one index, and this is where the data is stored. And basically all tables from the public schema in Postgres are replicated to this public index here. And you can see there's now one piece of data there. One thing that you might notice already is that the field names are named quite kind of weirdly. There's this ID and 2 and 3. That is because we're creating stable column IDs. We give basically each table and each column in Postgres an ID, so that we can follow them across renames and things like that. And then you have to resolve this back. I'll talk a little bit about how. And you've noticed that I did a create table here. I didn't have to do anything on the OpenSearch side. And you'll see that what pgstream did is pgstream created this index with the right mapping. If you look at the mapping for public one, you see that it has those explicitly defined. So these are not dynamically mapped. They are defined by pgstream. And if we look into the pgstream index, we'll see that the schema definition is there. It's JSON in JSON kind of, so it's a little bit hard to follow, but you can see it here. You see the tables, and there's the employees tables, and then the columns, and it's all defined in there. All right, that was like a simple insert, and now let's do a simple update. I'll go here and edit the update. If I now search here, it should say yes, it's assistant to the regional manager, so that the update was replicated. This is all happening async, so sometimes I might have to refresh a couple of times, but yeah, that's the point. It keeps it in sync. And now let's show a delete as well. I'll just do the delete command. And if I go here, as I was saying, I might have to wait a little bit. And now it's gone. It's just deleted by the ID. And this also works for truncate. So if I, insert it a few times, wait for it here, you see there are a bunch of them, and I do truncate employees, and now they will all be gone when it refreshes. There you go. So those are the the simple, the happy path, if you want. Now let's see some of the common issues that one might have, and things that pgstream handles. Some of them pgstream handles today. For others, we have workarounds. For others, they're kind of on the roadmap, and hopefully, we'll have a solution soon. One is this, which I already mentioned, the column renames and resolving the IDs. Because we wanted to be able to follow a column across renames, like if you alter it and change it names in Postgres, we didn't want to have to reindex the whole data in OpenSearch. That's why we give them names, we give them IDs here. But the issue is, let me add back the data here. The issue is that then your application will have to know about those IDs and map them back, which it can do by calling, for example, looking into the pgstream index and getting the mapping from here. This is what we do internally. Or what I have experimented with is to add field aliases for them. So if I do, for example, this, but I have to update the actual names. 1 second. I think if I do this and put it here, then it should work. 1 second. Because this is from a previous run, and the IDs have changed, of course. Let's see if that works. Okay, that worked. And now we have the aliases defined as well. And then the query needs to be a little bit different as well. So to select the fields by their names. And that works. Now you get the name and role with their actual names. We're thinking pgstream can maintain this list of aliases all the time. There is the drawback that this show up as arrays now instead of simple keys. I'm actually not so sure why. If anyone knows a better way of doing this, I will want to know about it. But yeah, that's one. Then another one is in some cases, even if we do these things with the IDs, in some cases you might still need to reindex. That means to take all the data again and recreate the index in OpenSearch. That can happen if you're changing a column in Postgres to an incompatible type, like you had the column that was an integer and you are changing it to a text. You can do that in Postgres. It will be able to do it with an alter table statement, but then it's going to be wrong in OpenSearch, and it's going to refuse it, and you're getting issues. Or another example, if you add a column with a default value, Postgres is pretty smart about it, so it's not going to touch all the existing rows. It will just remember that, okay, for all these rows, the default value is now this one. But that means that there won't be updates to be sent to OpenSearch, which means that the only solution really is to do a reindex now. The way we do it is to basically force an update to everything in that table or set of tables, which can be done with something like update employees set ID equals ID or something like this. It doesn't actually matter what you do. This will force then an update, and then you can rotate the index if you want. So delete the old one, create a new one, or increment the number. So you can work around that way. In the future, we want to improve this, and this will show up in our roadmap. Then there's the issue of large values. The thing is, in a Postgres, values that don't fit in a single page, typically 8K of data. If you have a value that's larger than that, then Postgres will store it separately, which is great, but it means that sometimes that won't show up in the replication stream. And if it is modified in the current transaction, then it will show up because it has the value. But if it's not, if another column is modified, then by default, it won't show up there. There is a solution for that. It's called setting replica identity to full. It's not a default in Postgres because it has some performance implication. And I actually wrote a blog post about it. For this for this particular use case, it's actually what you want, but you need to enable it. And then pgstream does the rest of the work of merging them correctly into the document, so you don't have that issue. Then there's the issue of out-of-order events. Basically, at some point in your scaling story, you might want to run multiple pgstreams between Kafka and OpenSearch, for example, here. This one needs to be only one because there's only one connection per replication slot. You could have multiple replication slots, but it's a bit of a different story. Anyway, if you're doing something like this, depending on how you do it, you might get events out of order. And then, there could be issues if there are two updates on the same document, but you process them in the wrong order, you might end up with the wrong result. The way to do that, to solve that if you want, is to set the version field in OpenSearch, and then OpenSearch will take the newest version. It will do the optimistic version control. And what the pgstream does for this is to use version as use the sequence numbers from the Postgres wall as the version. And you can see that if, for example, here I add the version true, you see now the version of this is this one, and this is just the offsetting to the Postgres replication log. So it's guaranteed to be always increasing for newer events. Then there's another tricky thing about reusing the IDs. We use by default, pgstream uses the primary key as the ID field. It's actually the ID of the table plus the primary key. In this case, the primary key is 7. If you have a composite primary key that also works, it will do a hash on it and put it here. So like it supports all these cases. The issue is if you could then delete it and recreate immediately one with the same ID, that can cause issues because OpenSearch keeps it around for 1 minute and then checks the versions and such. So the solution to that is basically to have IDs that are guaranteed to not repeat themselves. Like you just generate them. Then this is actually like, let's say, one of our biggest problems at the moment. There's this data model mismatch between Postgres and OpenSearch, right? Postgres is relational, which means that the best practice is to normalize your data and have junction table and this kind of stuff. OpenSearch is document oriented. The best practice is to put as much of stuff into the same documents. If you just replicate tables one by one, you're going to have tables that only contain some IDs, and those are not really useful for search, right? For now, the only solution that we have is to use the lookup processor in OpenSearch to look up values and enrich the data as it's come in. We are thinking of a better solution for that in pgstream. And that's about it. From the roadmap point of view, we will be focusing on the fast reindexing issue. You saw I just ran an update. That means it currently puts all the data through the replication slot again, which is not the fastest way of doing. It's faster if you actually query the data and merge them afterwards. So that's something we want to work on. The denormalization thing that I was talking about, support for multiple topics in Kafka, and then other outputs. First of all, we want this to be used for Postgres to Postgres replication as well. Currently, it's Postgres to OpenSearch, as I said. Then more outputs like ClickHouse, Nodeflake, like S3, these kind of things, and advanced data filtering. And that's about it from me. I'm curious. Yeah, let me know if you have any questions um, uh, about anything or about pgstream. Happy to take them.
Well, thanks for that, Tudor. If no one else is speaking up, I'm actually curious about one thing, and that is I'm seeing a lot of like I'm not sure if they're plugins or not for Postgres, but people are through whatever means are using Postgres for like vector databases and whatnot.
Yeah.
So would this successfully replicate vector to a vector database to an actual vector store in OpenSearch?
Yeah, you can do that. And if you store the vectors in Postgres, there's a couple of options. There's PG Vector, which is, I would say, the most popular extension for Postgres. But actually, if you just want to store them because Postgres is your source of truth and you don't want to do the actual vector search in Postgres, then you can store them as a simple array of numbers, or a simple array of floating point numbers. And then you replicate them to OpenSearch or like other vector database and do the search there. So that's also a way to do it. Depends on your constraints, your benchmarking, and all this kind of stuff.
Gotcha. Well, that's awesome. I think it's a useful tool, and it's a really cool way to kind of reach out for to the Postgres community who might be interested in taking up OpenSearch for whatever reason, getting AI summaries on their data, or just doing plain text search on some kind of information store. So awesome. You're enriching the community here. I appreciate it very much.
Absolutely. Thank you so much.
Yeah. Does anyone else have any questions for Tudor here? All right. Crickets. Siddharth, I think you are up. Please begin whenever you are comfortable.
So let me see if the screen is shared. And yeah, I want to thank Tudor for your presentation. It was really good. And it's a good problem. We tried to do something with ETLs at one point as an open source project. And I know that it's a good problem to be working on. So yeah, thanks for doing that. So reactive search is we supercharge the search and we do it in a incremental stack. So the the unique feature about reactive search is the open source UI libraries, which we have for React, Vue, JavaScript, and Flutter. Um, and today I'll be talking about the Flutter part of it. Reactive Search as a commercial product offers OpenSearch and Elasticsearch hosting. It has a cloud control plane where you can author a pipeline, essentially design your search backend, which could be just using one of the search engines. It could be connecting it to a LLM service. It could be doing some more things with it. And these are JavaScript stages that run in V8 engine. And so the speciality of the search pipelines is that they are executed in a low latency manner. The hosting part is optional, so you could choose to host OpenSearch with AWS. And then we have an open source version of the server, which you would run as a server, and then you could use the UI libraries. The UI libraries are also open source and Apache 2 licensed. So that's a little bit about reactive search. My name is Siddharth, and I'm the founder and CEO of Reactive Search. transition to talking a little bit about the UI libraries itself. So we have about React is the most complete library, and the benefit of using, let's say, reactive search is it's going to save time in terms of building the user interface components. There's about 30 pre-built components that you could get with reactive search, or you could use just some of the components. You could benefit from the state management by incrementally moving any of your search components to using reactive search as well. And then we have libraries for charts and maps. So if you were to build something with, for example, Apache, so this is using Apache eCharts behind the scenes. So anything that would be a more programmatic driven interface, like a SAS dashboard, you could combine it with search, and you could have it. So I would say OpenSearch dashboards is a great fit for where you don't need programmatic things, but then when you do, then this could be an option. And Maps is extending the reactivity of search to essentially having it with OpenStreetMaps, Google Maps, doing places search, and then you can combine any of the search parts with it. Okay, I'll get to the Flutter Searchbox. So Flutter Searchbox is just a Searchbox library. It only does one thing, which is it offers a Searchbox widget in Flutter, and you could build a search UI with it. So I'll start with a demo, and this is our most simple search interface, which has a search UI. It is doing something like recent searches. These were some things I had searched on before. And now, just want to make sure the screen share is working okay. And just let me know if there's any about it.
Looks
I'm going to
good to me.
look at it here. Okay, thanks. Thanks for letting me know. All right. And then when we search, we are going to see the results, and it is, I would say, the core use case for the Searchbox library. You could extend it then. So while we don't offer anything beyond the Searchbox, there's a search widget connector, and you could extend it to build a custom widget, like a facet that would go along with it. Or we could have a result widget that can do some other things. So we'll take a look at some of these things in a bit. What I would like to do for the demo is go through the quick start guide and essentially run this and see how the process looks like to do it. So I have one already running here. So I'll just start and call this demo number 2. And this is me getting a Flutter project set up. Once we get the project set up, we are going to go to the pub/spec.yaml, and we will add the library dependency. So Flutter Searchbox depends on Searchbase, which is a Dart library, which offers state management and common utility methods to work with OpenSearch or Elasticsearch. it's not really about the user interface, but it's more about just being able to do state management. So in the dependencies, we'll add Flutter Searchbox and search base. And then we will install the dependencies. So this should be Flutter get. And once we have the dependencies installed, I would take this basic example and copy it into the lib main.dart. And with this in place, I think you would like to, so we'll be running this with the iOS simulator over here. We'll just do a Flutter run once you have the simulator open. This is all it takes.
Which iOS simulator are you using there?
This is the one that comes built in with the Flutter dev tools. So
Gotcha.
it's part of the Xcode. And yeah, we get the pretty much the same app that I was showing earlier. And there are some changes in the config. So it's not showing the recent searches because they are perhaps not enabled. And then we can search and we can see the results. Over here, looks like there's some CSS exceptions, which are really about rendering of the content. Can take maybe something else for now. Yeah. So we'll take a look a little bit at the code now. So here what's going is first we are connecting to the search cluster. So this is a hosted version of ReactiveSearch, which is using Elasticsearch 7.10.2, but you could use with OpenSearch, with Elasticsearch, either of the two. And then this is the index in the cluster. And these are some settings specific to ReactiveSearch about whether you would like to enable analytics and such. After that, we essentially have the main widget, which is present over here. So this is what is rendering the screen that we are taking a look at here. Could show the two side by side. And the main search is here. So I think the recent searches in the code here is set to false. So for example, we could set it to true. And I'll also set the enable popular suggestions to true. And we can do a hot reload, and that should get us the recent suggestions here again. So this is a API reference that is followed by the ReactiveSearch UI library. So we have a pretty similar reference that we follow across. So should be over here. This is maybe a very basic example with just setting the size and which fields to query. And then this has the usage with all the possible props that are available. So it's not using the OpenSearch query DSL directly, but it's rather capturing the search intent with things like which fields to query, whether you want the query to be fuzzy, whether you want to use search operators, do you like highlighting? And it maps pretty closely to what would be equivalence in the OpenSearch DSL, I would say. So aggregation size, sort by, and maybe we can take a look at one example by saying the query format. So this has two values that you can use. One is or and one is and. The and is the strict version of querying the search. And so what it should do is only show things that are exactly matching for all the terms. If I search for Harry Potter from 28, it brings things to 17, and I would say it would be the 17 that have both the terms Harry and Potter matching. So essentially, it gives control over being able to build and use the query DSL. And one part is you could use query DSL through these two properties, default query and custom query. Generally not recommended, but in some cases you want to extend to do something that the library doesn't offer. You could use the query DSL, and then you're able to kind of build anything that is supported by the DSL in terms of search. Okay, so another demo that I could show is about building faceted search. And this one, I have it as an example from the library on GitHub. So actually I can show the path. We're here. So we are looking at Flutter, Searchbox, and example. And it's very similar, I would say. Let's take a look. So here, in addition to showing the search box and the results, we are also going to show the facet, which is about authors. And I would do a Flutter run, since I already have the dependencies installed in this case. Okay, so we show the facet through the drawer icon, and if I say select Stephen King, then it should now show me the books that are authored by Stephen King. And maybe there's no intersection between the two, right? So it's also like reactively updates. And I could now go and say, okay, for this query, there's only one author. And when I select that, I would see that author. So this is the code for it. I am not yeah, I'm not gonna be able to explain the details, but I would say this is like a custom component that's custom widget that's being written that does the drawer and faceting part, and it's utilizing the state management aspect of Searchbox. So to take a look at how it does that, here's kind of the piece. So we define that the results are dependent on both the search widget and the author filter. So when either of them changes, it would change the results. And the same is being declared in the filters. So when we changed the result search query, we could see that there were no results and there was only one author. And that's because this widget also depends on the search widget. So this could be a good example if you were to use Searchbox and you had your custom design that you wanted to bring. You could do it. You could do it in a way that this component is doing it. And we have one more library that is built on top of Flutter Searchbox. This is called the Flutter Searchbox UI, which offers some more specialized widgets. These were things that we saw some of our customers request. And we decided to essentially just publish them as a collection of components. So they are no different than a custom component or a custom widget that is utilizing the Flutter search box. But then you could take a look at their code as it is on GitHub. So if you were to build something, you could utilize what is already over here as a reference, or you could choose to use them as well. So there's 3 components or 3 widgets that this contains. One is range input. So this is like the equivalent of price filter or any kind of numeric data. Here's an example with years. The another one is map, which is essentially like, yeah, if you were building something that had a geopoint data type and you wanted to do a map query, then you would use the map widget. Selected filters is the equivalent of what you would see as when you have a search and maybe one or more facets, they would show as like the whole search being constructed, and you could decide to, unselect one or more items. So there's a widget that lets you do that. So these are some things that can help with speeding up if you are building a mobile user interface. And I would say that more likely we see that there are going to be things that our users would choose to customize in terms of the looks of the widgets or in terms of the functionality, because the Flutter library is not as full-fledged as the React version, which has about 30 components. We only have maybe 5 over here. So I would say, yeah, you could take a look at the library and you could do it. Now, this example uses the hosted version of Reactive Search to connect. And I would like to also mention that there is an open source version, so you could run this repository where we have a Docker Compose template, which lets you use OpenSearch as part of it, or you could perhaps use a hosted OpenSearch by simply setting the URL of your hosted OpenSearch. And in this way, you can use the entire stack by, yeah, you would have to run a server process, but that's effectively it. And you'd be able to leverage everything that Reactive Search offers and the user interface aspects. of it. So yeah, I would like to see if there are any questions. This is the whole of the presentation. Thank you.
It's actually a situation that I find myself in occasionally where I just need a quick search interface for something and I need to spin something up pretty quick. It seems like there's a lot of ways to save time with generic implementations of search there. Some assembly required, it looks like, but yeah, the tool looks very useful. I appreciate you sharing it with us.
Thanks.
Any questions for our presenters? I'll take that in the negative. All right, well, we're just about on the hour. I have no further announcements or introductions to make to anyone. Would anyone like to take the floor for anything for the good of the order? Nobody. Do we have any that I see a few names I don't recognize in the crowd here? Do we have any first timers? Anyone who's comfortable announcing themselves as first timer, don't out yourself if you don't want to.
It's like Esther's first
Actually,
timer.
Esther is the main developer at pgstream. This is why she's
Oh, okay.
here.
Oh, cool.
Actually didn't know earlier if I should call out to her. I don't know if she wants to say anything.
Esther's here to make sure you're doing it right, Tudor?
Yeah. To correct all
Perfect.
the
Thank you.
false things I said.
Awesome.
Wonderful. Okay. Well, I think let's call it.
Yeah. Thank you both for being here. We really appreciate that.
Keep on searching, everybody.